All right, today we're doing laws of exponents. We're doing algebraic expressions. You do have a quiz on this tomorrow. I saw most of you didn't watch the videos in Savas or even attempt the work in Savas. So hopefully after this video, you will get it done. We are back in our books. We're on page 92. And basically what we're going to be using is all of our laws of exponents to kind of mix and mingle and play with all of our a bunch of different monomial expressions. If you forgot them or you need a quick study guide, on the top of page 94, this is an amazing chart. A little bit hard to read in my opinion. You should have notes on all of these because I gave them to you. But just in case you lost them, here is a charty chart of all of your exponent laws, top of page 94. So take some time to study them, make some index cards, do what you got to do. But these, a mix and mashup of all of these are what we're going to be using. So the first part of the lesson is to just kind of play around and write them in different ways. We're going to use the laws to write them in different ways. You can kind of choose. I don't really care how you do it, but they will give you some hints. So, like for example, with A, bottom of 92, by the way. So when we're looking at A, it wants us to take the third power away. So essentially cube root everything here. So we would take the cube root of 27. We would take the cube root of A cubed, and we would take the cube root of B cubed. So what is 27, or what times what is 27? You get 3. And then the cube root of A to the third is just A. And then the cube root of B to the third is just B. So we're basically just taking the 3 out and then putting it around in parentheses. They have the same value. It's just if we were to distribute, we're basically undistributing here. We're taking the 3, the cube, essentially out of all of these and just putting it in parentheses and then throwing it on the end. So we're doing the opposite of distributing. For this one, they want us to use one of our powers. We have to get 6 and use multiplication. So our rule states that if it's the same base, what math do we use with our exponents? Addition. Yay! So what can we add to 2 to get 6? Hopefully you said 4. So here we're just breaking it up. Same base multiplication. We need to add our exponents. 2 plus 4 is 6. So we're essentially working backwards. Here, a little bit different. This would be our power to a power. So we're not doing what we did up here because we're not taking the square root of all of these. This is power of a power. I guess technically it is up here too. We took the square root of 25. Okay, fine. What times 2 is going to give us 10? So what does the m power have to be? Because if we would multiply them, power of a power says multiply. So what times 2 gives us 10? 5. And what times 2 gives us 14? Hopefully you said 7. I guess that works here too, because it would be 1. So 1 times 3 and 1 times 3, you'd still get 3. But this one was a little bit different because they were all cubed. This one is not squares. Either way, it works out. So again, power of a power states 5 times 2, 10, 7 times 2, 14. Because when you're multiplying, when you have parentheses, it's power to a power. All right. 93, the bottom of 93 is where most of you guys are going to go, yeah, I don't want to do this. But you can, I promise you can. You just have to break it up. So for this, I am going to use some colors to make it easier for you guys to see. I really feel like for this, you need to be using line paper or graph paper. If you try to do it all in a little tiny space, it's just going to get crazy, in my personal opinion. So PEMDAS still applies. We're still going to work, you know, in order. So the first thing that we see here is that we have parentheses and a 4, which means that everything inside needs to be multiplied by the power of 4. So we're going to be Oprah. You get a 4, and you get a 4, and you get, oh, okay, that didn't work. You get a 4, and you get a 4. So v to the first power times the power of 4 is just going to be v to the 4. W to the second power times the power of 4 is going to be W8, because that's power of a power. Then we're going to say V to the third power times the power of 4 is going to be V to the 12, because it's power of a power, 3 times 4. And then W to the first power times the power of 4 is W4. Okay, so the first thing we had to do was distribute. We did that. We're good. Now, if you look, we all know fractions is just fancy division. But hear me out. We have 4 V's. We're going to separate these. We're going to look at our V's first. We'll look at our W's later. We have 4 V's on top and 12 V's on the bottom. So I told you, you have to subtract bottom from top. So 4 minus 12 is going to give you a negative number. You already know that. But the beauty of division is that you can cancel things out. So if you have 4 V's on the top, 1 times V times V times V, because that's what essentially, not essentially, that's exactly what exponents are. And how many V's do we have on the bottom? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we can cross off anything that's in the top and the bottom, we can cross off. So we have 1, 2, 3, 4, 1, 2, 3, 4. You are not going to leave negative exponents. So how many V's do we need to stay in our denominator? 1, 2, 3, 4, 5, 6, 7, 8. So 8 V's need to stay in our denominator. So I'm going to cross this 12. That one, those are all gone. We killed those 4. And 8 need to stay down here. Otherwise, we're going to have unhappy party guests. Nobody wants that in their life. We're done with our V's. Now we're going to go look at our W's. We have 8 in the top, 4 in the bottom. Subtract bottom from top. 8 minus 4 is a pretty number. So we'll let that one roll. 8 minus 4 is just 4. So these disappear and 4 W's get to stay in the top. What does that look like as an answer? It's going to be W4, because that's what's in our numerator, V8. These are not like terms. There's nothing else you can do. So you are done. Now, if you didn't like what I did down here and you're a creature of habit, no problemo. What do we have? V4, W8. We have V12, W4. Still do the subtraction. 4 minus 12 is negative 8. And then you're going to do 8 minus 4 is positive 4. So you would get V negative 8, W positive 4. But you can't leave a negative. It's unhappy in the numerator party. So you need to send it down to the denominator party where it's going to be happy. You're still going to get the same answer. W4, V8, again, not like terms, nothing else you could do. So you are donezo. I mean, when I say all the space, because now how am I supposed to do B? It's caca. Whatever. I'm going to work around it. Let's look at B. Anything to the 0 power is 1. So we're just going to make that a 1 right off the bat because I don't want to deal with it. And now all we have is a to the 5th times a. I'm going to squeeze it right here. A to the 5th times a to the 1st times 1. Well, what's a to the 5th times a to the 1st? And we're done. We did it. 5 plus 1 is 6. Oh, dang it. The light went off again. Hold, please. BRB. Okay, I'm back. Let's look at C. We're not gonna run out. We got this. No parentheses. We have M's and we have N's, but we don't have M&M's. We should have M&M's. One day I'll bring you M&M's. Not if you guys don't do your work though. No candy buckets. All 3 classes. I think 4 people did it in one class, 1 person in one class, and like 3 in another. So that's embarrassing for you guys. Just saying. Anyways, back to C. We have M3. I'm going to rewrite it. I don't like working in their tiny little space. N2 over M5. And then just N. We know N is to the 1st power. So again, if you want to work this way, you absolutely can. I prefer to just draw it out. M times M times M over 1, 2, 3, 4, 5. So I know I have 3 in the top and 5 in the bottom. That cancels. That cancels. 1, 2, 3. So I know I'm going to have 2 M's in my denominator. So that these all go away. And that goes away, and there's 2 left. And then I have 2 N's, N times N over N. And that cancels. So I'm going to have 1 N in the numerator. So that's a 1. That's a none. So now I have N1 over M2. And you are donezo. If you don't like it, M3, M2, M5, N1. 3 minus 5 is -2. 2 minus 1 is 1. So you get M -2, N1. M is not happy. Send it to the denominator party where it wants to be. N over M2. Either way, it's the same answer. And no, you don't have to put the 1 there. I don't know why I did. Just because I could. All right, last example for today. And then I will let you be. Uh-oh, what do we see? It's time to be Oprah. We're going to be Oprah with teal. Everybody gets a 2, exponent of 2, including the 3. You get an exponent of 2, you get an exponent of 2, and you get an exponent of 2. So we have 3 to the 2nd. What is -1 times 2? -2. And then we have 8 times 2, which is 16. 3 to the 2nd power. Anybody? Anybody? 3 times 3? 9. J to the -2. Uh-oh. What do we know about negatives? They're not happy at their party. What party does J want to go to? The denominator party. Is K happy? Is there any other terms that we can combine? Nope. I want a little quick here with my fraction bar. Please please. That was it. All you had to do was distribute and move. Much easier than it seemed, I'm sure. All right, guys, that is it. One step at a time, break them up, get rid of the zeros. I mean, don't go crazy. You just got to know your rules, and you got to do your order of operations, okay? All right, kiddos, you got this.